MES College Marampally e-learning.
Dear students, today we are going to discuss the practical connections of half-wave rectifier. The diagram of half-wave rectifier is shown in the figure. Before we are connecting the circuit in the real world, we will do the simulation of half-wave rectifier in a software like Livewire. This is the Livewire software. In this software we can add power source, transformer, then we are adding transformer. Next we want to add the diode. For that we can select the diode and drag and drop to the window, aligning the component into the right position so that the circuit will appear in a neat condition. Then we will add the load resistor. We place the load resistor in a right position. The next step is to wire the connections between the power source, transformer and the diode. The connections are shown in the first section of this video. The circuit diagram shown in the first section. According to the circuit diagram, we will draw the circuit in Livewire. We made the connection from the power source and to the transformer. We are connecting the secondary lead of the transformer into diode. Then the output connection to the load resistor, and the common connection is connected to the center tap of the transformer. The center tap is connected to the common ground. So for measuring the output waveform, we will have to add the measurement device like CRO. We have to measure the input waveform and as well as the output waveform. So we are adding two CROs for measuring the input waveform. The first VRO we are placing. The connection is given to the CRO from the input side so that we can see the input waveform, and we are also adding the graph for the CRO. In this graph we will see the waveform of input signal, and we are also adding another CRO that will measure the output waveform of the half-wave rectifier. We are making the connections from the circuit, and also we are adding one more graph for the second CRO, and after that we will start the simulation. According to this simulation, we will see the input waveform is a pure sine wave and the output waveform is the rectified waveform, that is the half-wave rectified waveform that is shown in the graph. According to the theory, only the positive half cycle is conducting through the diode, so we will got only the positive half cycle in the output. This is the common principle of half-wave rectifier. Let's see how the connections physically doing in the next part of the video.
Okay, so we're gonna make the circuit diagram on the breadboard. These are the components we need for that. And here I'm taking a 100 μF capacitor for filtering, and a 1 kilo ohm resistor, and a diode 1N4001. And if you want, then you can use a multimeter. And this is a transformer of 15 volt peak to peak. That means 7.5 volt positive peak and 7.5 volt negative peak. Okay, so by using these components we are going to make the circuit diagram. And if you are going to make a full wave rectifier, you need two 1N4001 diode, and if you are using a bridge, if you are doing a bridge circuit, then you need 4 diode. So here we go. I'm taking a transformer of 15 volt peak to peak. That means I'm getting 15 volt in the secondary of the transformer. So basically this transformer has 3 end, one upper terminal, one lower terminal, and a center tap. Okay, here I'm taking one terminal and the center tap for the half wave rectifier. So the connections are like that. I'm going to make the connection as per the circuit diagram is always shown. So the positive terminal or 1N terminal is for the input voltage that I'm giving, and we know that most of the electronic components as indicating the negative terminal of the component. So here in diode, the white ring is representing the negative terminal of the diode. So I am going to connect the positive terminal of the diode to the one terminal. As already said, the negative terminal is going to the ground section. So this 1 kilo ohm resistor I am using to connect series with the diode. That means the negative terminal of the diode is connecting to the one end of the resistor, and the other end, I mean the center tap of the secondary of the transformer, is going to connect the other end of the resistor. This is the connection for the half wave rectifier. Yeah, so our connection is over. Then now we are going to connect the CRO with the input and output terminal of the circuit. So we are using the two channels of the CRO simultaneously for the input and output, and we are going to measure the maximum voltage and then the calculation. So the input waveform is look like this. So channel 1 is used for to measure the input waveform. We are putting the voltage per division in 5 volt and the time period is 10 millisecond here. So by these measurements we are going to measure the voltage of the input waveform. The channel 2 is used for the, as you are right now you are seeing the output waveform of the half wave rectifier. We are using channel 2 for the output waveform. If you want to see both input and output at the same time, you can put the CRO status into dual, then you can see the input and output. So by this we are going to measure the voltages and the ripples, and we are going to make the calculations. So from the CRO we have to calculate the ripple factor from the CRO measurement. So we have VM, maximum voltage, equal to 9.5 volt. Therefore the equation for VRMS equal to, that means the root mean square value of the voltage, equal to VM by 2, that is equal to 9.5 divided by 2, which is equal to 4.7 volt, which is the VRMS value. Now we have to calculate the VDC to calculate the ripple factor of the half wave rectifier. Okay, so VDC, we have VDC equal to Vm divided by pi, which is equal to 9.5 divided by 3.1415, which is the value of pi, that is equal to 3.0240. So here we got the VRMS value is 4.75 volt and VDC equal to 3.0240. Then we have to find, now we can calculate the ripple factor by the equation ripple factor equal to root of VRMS divided by VDC the whole square minus 1. So putting the value of VRMS, that means the root means square value of the input voltage, and the VDC value, which is equal to 3.0240. In the ripple factor equation, we are getting 4.75 divided by 3.0240, the whole square minus 1. Then we have to take the root of the value. That means root of 1.467, which is equal to 1.211. So here is the value of the ripple factor of half wave rectifier without filter, which is equal to 1.21.